In this problem we're asked to find the sign distribution for the second derivative of the function given and determine where the function is concave up and concave down in the inflection points. They don't specifically ask for concave up, but the technique we'll use will discover concave up, concave down, and inflection points. And that's essentially just studying the second derivative of the function, and we will use the sign distribution as suggested in the problem. So to begin with, we'll find the first two derivatives of the function. The function's x to the fourth minus 2x cubed. It's a polynomial, so the derivative is pretty straightforward. We bring the exponent down, reduce the exponent by 1, and repeat for each term. In this case, we'll get a 6x squared from the derivative of 2x cubed. The second derivative, then, is a repeat. You just find the derivative of the first derivative. In this case, we'll get a 12x squared when we bring the 3 down, reduce the exponent by 1, and we will get a 12x from the derivative of 6x squared. We're now interested in finding the zeros for f double prime. In general, in a second derivative problem, we'd be looking for zeros or DNEs, but since this function is a polynomial, it exists everywhere, and so does its derivatives. So we won't expect to find at least DNEs. There won't be any, but we factor out any common terms and look for zeros. In this case, I can see a 12 and an x, leaving behind an x in the first piece and a 1 in the second. So we've got 12x times x minus 1. We now search for zeros for this. This will be 0 if x equals 0 or if x equals 1. From this, we can check the sign distribution for the second derivative and discover what's going on at 0 and 1. Alright, so we'll mark the 0 and the 1 on the x portion of this number line, and the second derivative will contain the sign of the second derivative. To the right of 1, both terms here will end up being positive. So in this region, from 1 to infinity, the function f would be concave up, that shape. Alright, some portion of this shape at least. In between 0 and 1, the 12x will be positive, but the x minus 1 will be negative. So we'll have a positive number times a negative number, and the result then is negative. And that means our shape is some portion of the frown. It's concave down. In between 0 and negative infinity, the 12x term will now be negative. X is negative, so 12 times x is negative. And if I subtract 1 from my negative number, I also get a negative. The product of these two negative numbers now will be positive, and so in this region we're back to concave up. We can now start to answer the questions that were asked of us. Since the sign did change from positive to negative, there is an inflection point. The inflection point has x value 0 and y value f of 0. So this will be 0, comma, if I plug in a 0 into the function, I get a 0 out. So 0, 0, the origin in this case, is an inflection point. Over here at x equal 1, the sign changes there as well. So we have another inflection point, and that inflection point has coordinates 1, f of 1,